Hi everyone. Today we are going to deal with scalars and vectors. So it is prerequisites for your electromagnetics. So let us first define what is a scalar and then what is a vector. So scalar is nothing but any physical quantity which has only magnitude and no direction. So which means that we are going to represent only its value by representing it by a real number, any real number. Either it may be positive or negative. So we will not talk about which direction it is propagating. So we are only talking about the value. So the number. Okay, for example, so if you talk about distance, we only say it is so many kilometers. So we are going to talk only about the value 10. So it is 10 kilometers. So or it may be 50 kilometers or 50 meters. So what does it mean? So we are representing that parameter only with the number, that is called the magnitude. Okay, such type of quantities, so we call it as a scalar. So one is a distance. Similarly, so we also may talk about temperature. So many degree Celsius. Okay, so it is say 25 degree Celsius. So there is some value represented as 25. So not by direction. Any quantity so which is represented only with its magnitude. So only value, only with the number. Then such type of quantities. So we call it as a scalar. Similarly, so when you talk about mass, it may be so many 53 kgs. So we are all talking about the value only here. So similarly for the other parameters also, all these are the examples of your scalar quantities. So then what is a scalar field? So when you talk about scalar field, so it is the region where you are measuring the quantity. So it is the region where you are measuring the scalar quantity. So we understood what is scalar quantity. So now let us measure. So what is the region at which, for example, so temperature is a scalar. So temperature is a scalar quantity. So we are measuring temperature of this room. So this is a region. This is the region where we are measuring the scalar quantity. Similarly, so distance is a scalar quantity. So I am measuring what is the distance from Bangalore to Chennai. So like this, so if you are talking about the region as well, so where you are measuring the scalar quantity, such type of fields, we call it as scalar field. Similarly, mass of your body. Mass is a scalar quantity. So, and you are measuring on a body. So what is the mass of your body? So this body is your region and you are measuring the scalar quantity as mass. So therefore, so this becomes scalar field. So hope you understood what is scalar. So what is scalar field? Similarly, so it is very important to know the other parameter called vector. So here what is vector is similar to scalar. So it has a magnitude. It has a magnitude. Along with that, so you also have direction. So if any quantity which is represented both in its magnitude as well as direction, then such type of physical quantities, so we call it as a vector. So some examples of vector are, so it may be displacement. So displacement means, so we talk about distance from initial point to final point. So the shortest path we are going to take it. So this is the direction. So we talk about, so this is your 10 meters from initial point A to final point B. This is called displacement. Along with the magnitude, so I am also indicating, so from where to where, which direction. Okay. So similarly, so next is velocity. So many kilometers per hour in a given direction. Similarly, acceleration, force. So force is also a vector quantity. All these are the vector quantities which will have some magnitude. So along with this magnitude, so we also talk about in which direction so it is measured. So along with magnitude, so we also talk about direction. Such type of quantities, so we call it as, so physical quantities we call it as vectors. So these are, we have many such examples. So few are listed here. So you will understand this vector better. So when you talk about vector field, as I already said, what is field? So it is a region where you measure this quantity. So now it is a vector field, therefore it is the region where you are measuring, so vector field. So it is a region where you are measuring vector quantity. So this quantity is measured in a given region. For example, I said displacement is a vector. So we measure displacement of a bird. For example, at this point of time the bird is here. After some time, so the bird may move to some other distance. Okay, so let me say this is the point. Now this is a displacement, so of a bird is moving from here to there, okay, in this direction. So therefore it is a displacement of a bird. So we talk about how much is the distance between those 2 points and from where to where. So we also talk about the direction. So next is, so velocity of the bike. So at what speed the bike is moving from one point to other point. So many kilometers per hour. So next we talk about the force, gravitational force. So we all know that whenever you consider a earth surface, the force will act towards the earth surface. Suppose if this is a earth surface, so the gravitational force is towards the earth. So we not only talk about, so value, the number, so we also talk about, so which direction it is propagating. Such type of fields we call it as vector field. Till now we have studied what is a vector and vector field. Now we will see how these vectors can be represented. So for example, you have a point O. Suppose from this point O, so we have another point, let me say A. And from O to A means the direction will be like this. So this is a vector because it has a direction and also some distance. So that means a magnitude. So this can be represented as, so vector OA starting from O, it is ending at A. So this is represented as vector OA. So this is where, so the top of the notation OA you are indicating is arrow. This arrow indicates it is a vector. Or so in some textbooks, so it may be given it as OA with bold letters. Okay, so with bold letters, if OA is indicated, still it is called as a vector. So or OA on the top, normally we will have, so what is the direction. So this is called vector OA. This is how we represent any vector, starting point and initial point. So or in general, I can also say it is vector A. Sometimes, so we also represent it as vector A, some notation A, but on the top of the letter you have an arrow which indicates it is a vector. So now, as we know according to definition of vector, so how you can represent, suppose if I say OA is a vector, so vector means on the top we will be writing arrow, so which is equals to, so it will have some magnitude which I will call it as magnitude of OA. This is how I write it, magnitude of OA. So then into, it will also have some direction. So this direction, so I will represent it as A cap. So which we call it as unit vector, and this is for the vector OA. So I will repeat. So this is a vector OA, so which is equals to, it will have its magnitude, that is OA, into unit vector A cap OA. So if I want what is this unit vector, so I will send to the denominator. So if I want what is unit vector a cap starting from O to A, so which can be represented as vector OA divided by so magnitude of vector OA. So this we call it as a unit vector. So mathematically what is unit vector is, so any vector by its magnitude, so we call it as unit vector. Why the name unit? So we know what is vector, why the name unit? So when you talk about unit vector, the name itself indicates, so the vector will have magnitude if the vector has a magnitude which is equals to 1, unity. So if the vector is having a magnitude which is equals to 1, then we call such type of vectors is unit vector. Therefore, if I write this magnitude of this vector, so you know how to calculate a unit vector. So that is any vector by its magnitude you will get a unit vector. So if you want what is the magnitude of unit vector, so if you calculate, so what is the magnitude of unit vector, so it will be always equals to 1.